I'm using the Kinect's gestures to be able to zoom in, and we can look at the habitation modules, the arms. I can also give it voice commands. So I can say, time, real time. We can move away from the Earth, and we can see right here that besides the International Space Station, which is our permanent manned facility in which many countries of the world are providing astronauts and services and experiments up, we also have a lot of other satellites up here. And we can see ones in low Earth orbits and some in very elliptical orbits. And then the green ones here are the communication satellites. They give us TV and international phone calls. Coming away from here, we can see that it's a little hard to find planets and stars and things like that just by looking at them. So we'll get some help here. Orbits on. And here now we can see the orbits of these planets. It'd be helpful if we can dim the lights. I don't know if we can do that because they're washing out the display a little bit. We're looking right now at the inner planets. We're coming out here and we can see out to the orbit of Pluto. When I grew up, Pluto was a planet. It's not anymore, and I'll give you a little reason why. Asteroids on. So now we're looking at, see all those little white dots? Those are all asteroids similar to Pluto in their orbit, and that they're fairly eccentric. And we either had to promote all those to be planets too, and you'd have to come up with a very long sentence. My very exceptional mother just made us 2,000 pages of documents to remember the planet's name. So that's why Pluto got promoted. Solar system overview. We're going to fly back and orient ourselves based on the solar system right now. And so we're going to take you from where we're at here. Let's see. Time, really, really fast. Time, super fast. Well, maybe it's not fast enough. Time, faster.
So fast we can't see it.
Time, really, really fast. Okay, well, we'll have to get time going really fast because we have a limited amount of time here. So I'm going to take you now outside of the Milky Way. This is our home galaxy. From the inside out, we just see kind of through the band of it. It looks like a ring around us in the sky. But this is an artist's conception actually created by a science program, Spitzer Science Center, Dr. Robert Hurt. And it is, since we can't actually go outside our galaxy, we have to sort of reconstruct it from the inside out. But now I'm going to take you out to the large-scale structure of the universe. And this right here is 1 million galaxies from the Sloan Digital Sky Survey. And we're actually able to come in here and take a look at the structure of the universe. And not that it looks like an hourglass. That's only the fact that we're looking through the north and south of our galaxy, because looking through all the dust lanes is very unproductive. But this lets us actually look at the structure. If we right-clicked on any one of those galaxies, we could actually jump to the Sloan Digital Sky Survey data page on that and look at every observation. So I'm going to come in here and show you that besides being a time machine by going light years away and seeing things, we can also look forward in time. And we're going to go to August of 2017 on planet Earth. And within a day's drive of pretty much everybody in the United States, we can see the solar eclipse of our lifetime. So right here, we're showing you a simulation of the moon's shadow crossing the United States, and it's going to come in somewhere around Oregon. And as you can see, we have time sped up, and you can watch the satellites as they're orbiting in kind of hyperspeed. But what's making this happen is the alignment. So if we come out here, right here, we can see that there's the shadow of the moon, and we can come out and see right here that the moon is aligned there, and come out further. And see the moon, the earth, and the sun all in alignment, and that's what's giving us that eclipse. Sky mode. Now we're going to come in here and we're going to take a look at some of the imagery that's been captured. And this is the North American Nebula. And right here, we've captured this. This is the largest seamless panorama of any seamless subject matter. It's an all-sky image that's 1 trillion pixels, and it lets you see 1 arcsecond per pixel anywhere in the sky. We're going to go take a look at one of the Hubble images. We're going to go ahead and say, constellation figures on. Maybe it's figures on. Oh well. It's like my kids never listen. Okay, here we go. So here's the constellation, Ursa Major, and the Big Dipper. And we're going to go fly up here and see a Hubble image and show you the resolution that we can get. And this is a, how many pixels? 90 million pixel image. And we can zoom into it. And this computer was built fresh for this. So we're actually downloading the image on the fly over the internet on the shared wireless internet right now. So there's over 1 petabyte of information that you have access to. And you can come in here and explore star-forming regions that are 25 million light years away. And that's pretty far. So you can get this at worldwidetelescope.org and enjoy it yourself with your educator or researcher, or just want to explore the universe.